Hello everyone and welcome. This is an electronic calculator from 1967, the Olympia RAE 415-2. It was one of the first electronic calculators in commerce, and I think is the first Olympia's electronic calculator. Of course, you need a large desk, since the calculator is very big. It's a calculator without printer, performing basic operations, 3 main registers and 2 registers for storing numbers. It uses Nixie tubes in the display. These ones, very nice little lamps. Later I will show all the electronics boards inside, which are their functions, and the very fascinating core memory with toroid. This very big calculator full of electronic boards essentially perform basic mathematical operations and store some numbers in memory. So the performances are a little less than what a pocket calculator does today. At that time, mechanical calculators that had to perform complicated operations with memory were very big, having to resolve all the calculation with levers and gears. And in these early days of the electronics, this don't change. Electronic calculators are still very big. Miniaturization will arrive later. And now students can bring calculators with them, otherwise their life would have been difficult. The name RAE means Research Application Electronics. 4 indicate the 4 basic arithmetic operations. 15 indicates the maximum number of digits for results. 2 is the number of memory registers, in addition to the 3 arithmetic registers. For this calculator, doing multiplication takes 0.65 seconds. Back then it was fast. Now, with standard calculators, time is measured in millionths of a second, or billionths of a second. Astonishing. You see that there are a lot of electronic boards. Nowadays, a single board could be an electronic component. Or, most probably, a single electronic component performs the task of many of these electronic boards. These are the power supply electronic boards that are scattered all around. You see, there are a lot of electronic boards to manage the current. Now calculators are much more simple. This one is a kind of the electronic board bus. There are all the connections between the electronic boards, and here are all the main electronic boards. Let's start to see all these. This is the core memory. There are 6 matrices with 8 by 8 bits. Core memory is an old kind of memory that use these teeny magnetic rings called toroids. These toroids can be magnetized in 2 different ways, so giving a binary value of 1 or 0. The cores maintain the last value they had, even when power is turned off. Core memories required extremely careful manufacture, almost always carried out by hand. It's a kind of piece of art if you think that it was handmade. This is an output board. This board usually manages communication between the electronic board and the display. For example, it activates the correct number segments to form the visible digits and symbols. In short, it is the interface that translates internal calculations into visual information for the user. This board deals with digital output. It takes a sequence of binary numbers and decodes them to determine which number is, then physically activates on the display elements to reflect that number. Before going on, I remember when I was young, I repaired Olivetti electronic boards, but also I made connectors and adapters for Olivetti PC. It was my work, but I enjoyed a lot doing this. This is an intermediate register. It converts the binary numbers that the calculator uses into bits for the use in the memory. It also manages the transfer to memory, rounding, and other. This is the memory counter. In all the calculator electronics, numbers were stored in registers. The memory counter keeps track of the position of the data as it rotates within the registers. This is the clock distributor. In the machine of that era, there was no single all-in-one processor, so the various sections, memory, calculation unit, display, had to work in perfect synchrony. In short, the clock distributor is the metronome of electronics. It ensures that each component of the calculator takes its step exactly when expected by the logical sequence. There are some little dissipators. This is the memory counter. It is a fundamental logic component for managing data within internal memory. In short, it was the component that allowed the calculator to keep track of where the parts of a number were stored as they rapidly circulated as electrical impulses through logic circuits. This is the driver switch. It receives a weak signal from the logic board and transforms it into a signal powerful enough to light up the Nixie tubes of the display. In short, it's what transforms the calculator's results into electrical actions visible on the display. This is the program key. It's the part of the calculator that allows you to manage the memory of the instructions. For example, it could recall a preset formula, allowing the user to define and recall a series of operations in sequence. This is the function program board. It establishes the sequence of steps required to perform a specific operation. It acts as a director, coordinating the various parts of the machine to solve complex operations, such as multiplication or division. This is the special function board. For example, it performs decimal point calculations for multiplication and division. This is the comma program board. It is the unit that manages the decimal point position, ensuring that calculations are mathematically correct. In machines of that era, managing the decimal point was one of the most complex operations, as numbers were processed digit by digit. This is the function register. It is a temporary memory unit used to remember which mathematical operation the user had selected. It does not contain the actual numbers in the calculation, but rather the mathematical symbol pressed, allowing the calculator to know which operation to perform once all the data are ready. So, after removing all the electronic boards, we can see the inside of the calculator. While the electromechanical calculators manufactured some years before were mainly mechanical parts, in the 1970s there is mainly electronics. Okay, here are all the boards. It will take to me a couple of hours to put these again in the correct position. In 1960s, they had to use all these to do what now we can have in a single electronic component and carry it in our pocket. So I feel gratitude to all the engineers that permitted this. Otherwise, if you had to carry the calculator with you outside the house, you would have had to use some extra accessories, and that would not have been easy. Thanks for watching. Have a nice day.